The Big Bang theory predicts that all matter, time, and space began at an incredibly tiny compact state about 13.7 billion years ago. This initial state was a hot, dense, uniform soup of particles that filled space uniformly and was expanding rapidly. The scientists' observations of the movements of galaxies tell us that the universe is expanding at an accelerated rate. We have three main possible scenarios for how our universe is expected to end: the Big Freeze, the Big Crunch, and the Big Rip. The Big Freeze is what happens if the repulsive force pulling the objects apart is just strong enough so that the expansion of the universe wouldn't be able to accelerate anymore, but the universe would keep getting bigger. The universe would become darker and colder, approaching a frozen state also known as the Big Chill or the heat death of the universe. The Big Rip is what happens if the repulsive force was so strong and the expansion of the universe continues to accelerate. It will eventually overcome not only the gravitational force, but also it will overcome the electromagnetic, weak and strong nuclear forces, which hold atoms and nuclei together. As a result, the matter that makes up the stars breaks into tiny pieces. Even atoms and subatomic particles will be destroyed. The Big Crunch is what happens if the force of gravity brings the universe's expansion to a halt and then reverses it. Everything will be compressed into such a small space that even atoms and subatomic particles would have to crunch together. The result would be an incredibly dense, hot, compact universe, a lot like the state that preceded the Big Bang. When a gas is cooled down, the atoms slow down and their energies decrease. Due to the quantum nature of atoms, they behave as waves that increase in size as the temperature decreases. At very low temperatures, the size of the waves become larger than the average distance between two atoms. At this very low temperature, all of the bosons can be at the very same energy in the same quantum state. They all form a single collective quantum wave called a BoseEinstein condensate. As the universe is expected to become cooler and cooler, heading towards absolute zero, the Big Defreeze suggests that all matter, even if it's not a boson or ideal gas, are expected to form Bose-Einstein condensates, which could be considered as basically matter waves. We might face a problem with the fermions, but this is addressed in the book The Big Defreeze of the Universe. The Big Defreeze suggests that at the beginning of the universe, all matter formed a single collective quantum wave, which could be referred to as the identity stem wave of the universe. In other words, the universe was in a frozen state at almost absolute zero temperature and potentially shrunk in a very tiny collective wave. The thought experiment then suggests that our universe started with a reverse mechanism to a modified Big Freeze scenario. It started as a tiny collective quantum wave, which could be referred to as the identity stem wave of the universe. This stem wave started gaining energy, leading to fluctuations behaving in the manner of a string, forming what could be referred to as the identity stem waves of matter, leading to a supersymmetrical crystal with no well-defined boundaries. Where the identity stem waves of all elements started forming and interacting, this is so far pretty much what is generally expected anyways. The only difference is that the tiny condensed point from which our universe started was not initially hot. It was cold and it started gaining heat as per the Big Defreeze thought experiment. The frequencies of these identity stem waves are comparable to the temperature at which they form Bose-Einstein condensates. The thought experiment suggests using the Fourier transformation to test and measure the mechanism of forming the identity stem waves as spikes or fluctuations. It suggests a mechanism that breaks the symmetry of the supersymmetrical crystal, leading to an explosion or a big bang with a value comparable to the speed of light. In simpler words, this thought experiment suggests that our universe was frozen and it got heated to a degree leading to the Big Bang, and it is heading towards getting frozen again.